In this video, I'm just going to very quickly show you how to use Pythagoras' theorem. So I've got a right angle triangle here. We've got lengths of 5, 12, and x. And Pythagoras' theorem states that a squared plus b squared equals c squared. Now these values of a, b, and c represent the lengths on a right-angled triangle. And it's really important that you understand that the c, the value on its own, is the hypotenuse. So it's this one, and the hypotenuse is the longest side in the right angle triangle. It's the one facing the right angle. The a and b values are obviously these two sides here, the one adjacent to the right angle. It doesn't matter which way around we get these. So for example, we could have 5 squared plus 12 squared equals x squared. 5 squared, 25. 12 squared is 144 equals x squared. And 25 and 144 is 169. So x would be equal to the square root of 169. Just taking the square root of both sides there. So x is equal to 13. Let's have a look at this question here. We've got another right angle triangle with sides of 3 and 5 and x. And again, we've got Pythagoras' theorem stated up here. A squared plus b squared equals c squared, where if you recall, c, the length on its own, is the hypotenuse. And the hypotenuse is the one facing the right angle. So in this case, it's going to be 5. The a and b values are the ones adjacent to the right angle. It doesn't matter which way around we put these. So let's have x squared plus 3 squared is equal to 5 squared. Remember, the hypotenuse, the longest side, must be here. X squared plus 3 squared, we can write this as x squared plus 9 is equal to 25. Rearrange this to give x squared is equal to 25 minus 9. X squared is equal to 16. So square root of both sides will give x is the square root of 16, in which case x is equal to 4. If you found this video useful, then remember to give me a quick thumbs up. And if you would like to be notified when I release new videos, then hit that subscribe button and remember to click on the little notification bell.